That card got me thirsty. Pass me some water. Nour, it's way too hot. Go put it in the freezer to cool down.
Okay.
Nour,
What?
you fell asleep while waiting for the water. Nour, it's ice.
What's the difference?
Well, for starters, it's solid, so I can't drink it. There's 3 states of matter: solid, liquid, and gas. Solids have a definite shape and volume, like ice. Liquids have a definite volume, but not a definite shape, like water. Gas is the air around us. It doesn't have a definite shape or volume. This is a microscopic view of a solid. The particles are locked into place, and there's very little free space between them. They're rigid, so they don't flow easily, like a gas or a liquid. The lines on the balloons show how the solids vibrate instead of flow easily. This is a microscopic view of a liquid. In a liquid, the particles move, slide past one each other. There's little free space, and they flow easily, which is what the arrows represent. This is a microscopic view of a gas. In a gas, the particles can move past one another, and there's a lot of free space, as you can see. The particles flow easily, which is what the arrows represent.
So now I have a clear understanding of the states of matter, but why did the water become a solid?
It froze. Heat was removed from the water and kinetic energy was lost. The molecules slow down enough that their attractions arrange into fixed positions. The water freezes at 0 degrees Celsius. That's when it reaches freezing point. This is a phase change that requires energy being lost.
Oh, so a phase change happens. So does that mean the substance becomes something else?
Nope, a phase change is an example of a physical change. A physical change is when a substance does not become something new. A chemical change is when one or more substance becomes an entire new substance.
Okay, so how can I tell if it's physical or chemical?
Well, they have physical and chemical properties. A physical property is something that is measurable and observable, like density. A chemical property is something observed during a reaction in which the identity of a substance is changed, like reactivity with other chemicals. Now let's melt the ice to see what's going to happen.
Okay, so what happens to the molecules as it melts?
When something melts, it requires energy being gained. Heat is the transfer of energy from one object at a higher temperature to an object with a lower temperature. The heat molecules are colliding with other molecules of the ice, which passes kinetic energy and causes the molecules to move apart and enter the liquid phase.
Oh my god, Donald Trump is outside.
No way! Let's go beat him up! No, you're so dumb. It wasn't Donald Trump. It was the old man. Now look, the water's boiling. At a certain temperature called boiling point, which for water is 100 degrees Celsius, the molecules gain enough energy to break free and become a gas. In a liquid, the molecules are packed closely together and move past each other. As the temperature increases and reaches boiling point, the liquid turns into a gas, which is evaporation. This is why we see steam when water boils.
Man, you must be thirsty from all that science talk. Here you go, I'm gonna give you some water. Wait, why is there so much water out in the bottle?
This is called condensation. This is when gas becomes liquid. The molecules slow down and get closer together. When that happens, gaseous water vapor turns into liquid water droplets, which explains why there's water on the outside of the bottle.
Okay, I have one last question.
What is it?
What holds solids, liquids, and gases together?
That would be intermolecular forces. There are 3 kinds: hydrogen bonds, dispersion forces, and dipple-dipple forces. When water is in an ice form, the hydrogen bonds have a strong attraction. In the liquid state, the attraction isn't as strong as a solid, and when higher amounts of kinetic energy are transferred, the hydrogen bonds break and completely enter gaseous form.
That girl is